Hi, everybody. Mr. Rubo here. And today we are starting logs. What I want you guys to do first is actually this first page on page 12 here of the notes. Pretty much everything on here you can try on your own. It is all review from our last test with exponentials and inverses. So go ahead and try this out, pause the video, and then come back as you finish up. Okay, hopefully you paused it. Hopefully you tried it. The answers are on my Canvas page if you want to look there. But hopefully you got stuck when it came to number 5, right? So if you switch X and Y, you do this, and then you're like, oh no, what happens? Now, if you remember from last year, the way we fix this is with logs, okay? So we would switch this to exponential, or we switch this exponential to logs, and that's how we do the inverse of exponentials. So here is the definition. It is a logarithmic function to the base a, where a is greater than 0 and not 1. It's denoted by log base a of x. There you go. This right here is the important thing. It's the conversion between the two. Y equals log base a of x if and only if x equals a to the y. So we apply that to what we just had up here. You could see literally we have x equals a to the y. Our a here is 10. So this is going to change to y equals log base 10 of x. And now it's solved for y, and this would be the inverse, right? Now, you could memorize this, like just the way this switches. Another way you can do it, which is one way I show, is, hey, find your base. That goes as the base of the log. And then I draw like a circle. So I go to the other side of the equal sign, and that's the next thing I write right next to the 10. And then the last thing I write is that exponent right here. And it also works going the other way. So if I had a log and I wanted to write it as an exponent, I find the base. Base would be 10. I would raise it to the opposite side of the equal sign. So 10 to the y equals x. So again, this is a little circle. I like to do it. You do not have to. It's just a little technique I use. But you can also just memorize bases in the same spot, and the other two just switch, right? All right, so now when it goes to graphing, I want you guys to go ahead and try this out. So I want you to graph this first, and I will give you the hint to think of coordinate points, right? So, maybe graph 0 and 1, see what the y's are for this guy, and then as you recall from last chapter or from the last test, for an inverse, you switch x and y. So let's switch the x and y. So once you figure out these two, they're going to go here. Okay, and then plot those, and then just remember, because this is exponential, our horizontal is y equals 0. So if we switch x and y, well, same thing with horizontals here, y equals 0, it's going to switch to x equals 0. So we actually now have a vertical instead of a horizontal. So go ahead and try that one. Again, pause the video, try it out. And then, when you come back, I will go through it as well. Cool. All right, so you plugged in numbers. You got 1, you got 5. You plotted those, right? 0, 1, 1, 5. And then you graphed it. So this is f of x. And I'm switching colors here for some reason. And then I switch x and y, so this is 1 and this is 5. So I plot those points, 1, 0, 5, 1. And instead of a horizontal now, it's a vertical. And this right here is f inverse of x, which is our log graph. Okay, so log graph, exponential, there's the two versions. Okay, and you could see they do reflect over that y equals x line because they're inverses. Okay, all right, so let's go ahead and talk about some facts about logs. So the first one, x-intercept of a graph of just the basic one. This is the parent function, if you will, right? So a can be any number that's positive and not 1. But the x-intercept is always going to be 1, 0. And there is actually not going to be a y-intercept. Again, this will change if there's any shifts, but for the parent function, that's what it's always going to be. The vertical, we already talked about it. It's x equals 0. This is actually the same as it is for exponentials. If it's between 0 and 1, if the a value, then it decreases. And if it's greater than 1, then it's increasing. Like the one we just did looked like this. That was 5, log base 5 of x. And that was increasing, right? All right, the graph is smooth and continuous. I always spell that wrong. With no gaps or corners. That's actually a very important calculus concept, but we're not going to worry about that too much here. Okay, so now we have another definition here, which again, this is one that you've seen before, so it should hopefully be nothing new. We've talked a little bit about it last week, but we have the number e, right? And it is the number e. That's where we get natural logs. Okay, so we write it as ln of x. It's the same as saying that our base is e. So yeah, we just denote it ln. I like to write it like this. If you say ln of x, it's another way of writing it is log base e of x. Those two things are the same. Okay. All right, so now when dealing with logs, we actually use this property all the time. We did this a ton last test, right? If you have the same base, you can cancel them out and you just set the powers equal. That's going to be helpful in general, and you'll kind of see as we go here. All right, so for the first questions here, they want us to change each exponential equation to a log equation. So this is what I was talking about on the last page. Find your base. So that means it's going to be log base 4. So it's a little subscript. Okay, sometimes people write it as a big number. It's not. It's a tiny number. It's a little number below the inline. And then the next number you write is always across from the equal sign. So it's going to be log base 4 of 16 equals 2. And again, this is what I was talking about earlier with that circle. So here, same idea. Find the base first. So it's log base 5. Go to the other side of the equal of 6.7 equals x. And that's your answer. No difference here. Find your base. It's just x. Go to the other side. We get pi. And it's going to equal square root of 2. And there you go. So that's switching from exponential to log. Let's do it the other way. Again, same idea. Find the base, which is always going to be that small number. Okay, and there's only 2 incidences where it's not, and we'll talk about those later. But there's my base, 2. Go to the other side. That's my power, and then it equals 16. Really nice thing with going from log to exponential is if it's all numbers, it should be a true statement, right? If you mix this up and you add 2 to the 16th equals 4, well, you know something's wrong, right? Now, sometimes it's not helpful. Like here, we have an x involved, so we're going to say pi to the 1/3 equals x. Well, we don't know if that's right or wrong, but it's fine. And now this is one of those examples where I was talking about, hey, there's no little number, but we just talked about it. ln means log base e of 6. So if you want to rewrite it, feel free. Base is e, go to the x equals 6. Okay. So yeah, there is one other one that we'll talk about, I believe, tomorrow. But you already know it as well from last year. But, all right. So now we're going to talk about how to solve log or how to simplify logs in general. And then eventually we'll get to some properties that make this actually even quicker. So I don't know what this equals, so let's just say it equals x. Now we can do our little circle, and we could say 5 to the x equals 1 over 25. Reason that's helpful is now I can do my strategy of getting the same base. So 5 looks like a good base. To make 1 over 25 5 to some power, well, the 1 over means it's negative, 25 means it's squared. So 5's cancel, x equals negative 2. So that means this log base 5 of 1 over 25 is equal to negative 2. Again, same thing. You can do this. And again, we'll have a shorter way of doing this once we have some properties, but it's still good to know how to do it this way. So here we have 1/2 to the x equals 8. So let's make them all base 2. So it's 2 to the negative 1 equals 2 to the third. This is really negative x equals 3. So x equals negative 3, right? Because those two cancel. And then our last one, let's do it again. 6 to the x equals this number. Now, again, the fact that there's a root makes no difference. It's still just a thing inside of our log. So we set it equal. And now we get the same base. When I see that 36, I want to make it base 6. So this is going to be 6, and that's squared. And then the cube root is the 1/3 power. So power to a power means we multiply, so it's x equals 2/3. And there you go. There's your 3 answers. All right, so now number 4, we're going to find our base, find a, such that the graph of f of x equals log base a of x contains this point. Now, whenever you are asked about any function and you're told a coordinate point that is in that function, substitute it in. So we're going to say 3 equals log base a of 3. Let's solve for a. So a is in this base, so I'm going to rewrite this as an exponential. So a to the third equals 3. And then to solve this, because I want to solve for a, I cube root both sides. And I finally get that a is the cube root of 3. And that's what I was looking for. Ooh, I don't know why I missed the a there. So a equals cube root of 3. Okay. And yeah, it's an ugly number, but it still works. All right, so now the last one down here, and then that'll be it for this video. And you can then start your homework after that, which is on the next page, is about the domain. So the domain, if you look back at this graph that I did on the front page and that you did hopefully as well, you'll look and there's nothing on the left side of the graph. It's all to the right of 0. So our domain is from 0 to infinity, both exclusive, right? So both are not included. Well, that's true for anyone. It's like we have that restriction, but now we have some shifts. So the really nice thing is, just like square roots and cube roots, square roots and fourth roots, what we're going to do is we're going to take whatever's inside of the log, so usually what's inside the parentheses, and we're going to say it's got to be greater than 0. It's a little bit different than square roots because square roots are greater than or equal to. Logs are strictly greater than. Okay, and then we solve, and look at that. We write it in the nice format, right? X such that x is greater than 1. All right. Hey, look at this. Everyone's favorite. We'll skip that one, actually. We're going to go to C real quick because this one, again, you'll see all this other stuff. All that's going to change our domain, because domain is with the x, is the stuff inside of the log. So we're going to take that 2x plus 8, say it's bigger than 0, and solve it. So we say 2x is greater than negative 8, divide by 2. So x has to be bigger than negative 4. Again, put the nice set notation, or you could put in an interval if you wanted, but we need to have it in that proper notation, right? All right, let's go back to the one I skipped because it's everyone's favorite here. Starting off, same thing. You do what's on the inside has to be greater than 0. Now, if you recall though, and this is where some people make mistakes, is this is a rational function, not linear. So we can't just solve this. So this is where sign charts come in. And if you recall, you see a 0 at 0. So that's an x-intercept. And then, I did that in a weird spot. Let's go. And we have -1 as a vertical. And now we have to figure out where is it positive, because that's what we care about. But we'll just fill out the whole sign chart. So let's choose a number to plug in. So I'm going to plug in, let's say -2, right? So -2, plus 1 is -1. So negative over negative is positive. All multiplicities of 1. So I know it switches every time. And then my answer are these two sections, meaning it's from -infinity. Oops, I just hit the arrow key. Sorry about that. -infinity to -1, and then 0 to infinity. Really nice thing is it's always going to be parentheses with logs because they're not equal to 0. They're greater than 0, right? So this right here is our answer. All right, so your homework tonight is the next 2 pages. Just like always, put them on GoFormative. Take a couple pictures of them and put them on GoFormative when you're done. So thanks for watching and have a good day.